So let's begin with our session, that is select energy management measures and or what we call is as developing action plans. So so what aspects do we need to consider while we're developing action plans or selecting energy management measures? I would say first is we must establish and maintain process for identifying alternative solutions. So not all the problems have only one solution. There are problems which might have two, three, or four solutions even, and some solutions might be immediate solutions, some solutions might be long-term solutions. Some of these solutions might require low investment, some require high investment, but obviously then they also differ in the benefits that they provide. So there must be a process of how do we identify alternative solutions, and then we must develop a criteria in selection and provision of a balanced approach to cost, benefit, and risk. Then we must obtain complete requirements and allocation for each of the alternatives. How much time do we need to implement it? How many persons are needed? What are the social issues associated with it? What are the environmental benefits that come along with it? And then document the rationale for each of the alternatives, why we are selecting one alternative or we are preferring one alternative over the other alternatives. So we need to have a rationale to do that. So there's a process called DMAIC or MAIC. This is called differently in different frameworks. So if you are familiar with the framework of Six Sigma, which is quality management, they call it as DMAIC. That is this first process of describe or define the problem. They put it into a separate column, which they call it as D or define. So the DMAIC means define, measure, analyze, improve, and control. So this is a 12-step process where we describe a problem, what the problem actually is, where does it come from, and what kind of issues are we having here. Then we measure the magnitude of the problem. How big is the problem? For example, we say that we have steam leakages in the network. So the problem describes that we figured out that there are steam leakages at 100 areas where we have pipes, we have joints, and we have valves that are leaking. But what actually is the magnitude? Is this leakage big or is this leakage small? So here we need to define the quantity. Is this leakage amounting to 1 tons per hour or half tons of steam per hour? So what is the actual amount here? Then we determine when the problem actually started. So this we can determine if we have a monitoring framework. So we look at our previous reports of leakage assessment or previous report of steam balance, for example, and where we can see that there is a meter on the main header through which all the steam is going through. Let's imagine that 10 tons per hour steam is going through the main meter. Imagine that we have meters installed at all the demand sites wherever steam is being used, and they sum up to 9 tons per hour. So where did this 1 ton per hour steam go? So this is how we can see, based on the data that we have, that okay, 1 month ago we had a difference of only 0.5 tons per hour, and we thought that probably this difference is coming because there is a difference in measurement of the meters. But now this is increasing, and after few days we have come to a point where the difference is 1 ton per hour. So we keep on monitoring it. Probably again the problem is in monitoring. So we keep on monitoring, and with the evidence that there are leakages, and with the evidence that this data gap is increasing, we can safely recall that okay, 1 month ago we had 0.5 ton per hour gap, and probably 2 months ago we had a gap of only 0.25 tons per hour. So that is how we can somehow estimate where the problem and when the problem started. So don't look at these graphs at the moment. These graphs are there only to show as an example. At the moment I am just showing you the stages that there are there. So first stage was, as I said, first of all, we have to describe the problem. So what the problem exactly is, as I said, that taking a simpler example at the moment of a steam leakage. Okay, we saw that there are some steam leakages. So what is happening is that we have steam leakages. Where are these steam leakages happening? So these steam leakages are happening, for example, in 100 points or 120 points. So we identify which areas are the leakages coming from, and then the extent. So how many leakages are there? Then the magnitude of problem. So measuring the quantity of leakages, right? So how much is the quantity of leakages? There are different ways of doing it. So there is a method called an orifice method. If you estimate the size of the leakage and the length of the plume, then you can estimate the quantity of steam flow through it. But there are other methods. For example, if you go to engineering toolbox, you might find another graph which tells you if how much bar of pressure and what size of orifice would gives you how much quantity of the flow. But all these methods have their errors. So I usually do not use these methods to quantify the leakages, but only to show the people, to show the company that this is a way of doing it, and so the leakages are there, so that they know that there is a financial loss. But we do not calculate the actual financial loss using these estimation techniques, because they have a lot of errors in these calculations. Anyways, we have to calculate the total amount, okay, and then we determine when it started. So we look at the data. For example, in this case, we'll look at the uh, flow measurement of main header steam flow meter and all the demand side flow meters, and we see how much is the gap, and we see when did the gap started to happen, and how much has it come to this. So we know, for example, let's say if we had a gap of only zero point 0.2 or 0.25 or zero point 0.5 ton per hour, we can say that probably the line length is too long and there was condensation taking place. So the condensate was returning, and then there was this gap. But since we had a gap of 0.5 over the period of few months, but now the gap has elongated and it has become 1 ton per hour. So we know that we have a leakage of about 0.5 ton per hour. So this is how we can describe when it started and how much it is. It's only estimation, obviously, at this point. Number 4 would be to identify the root cause. So we come up to, maybe we come up to 4 or 5 probable root causes doing a root cause analysis. So this one way is to use a fishbone diagram. I will show you other ways as well. Fishbone can be used if we have a highly technical problem. But if we have problems where we have management systems also, management related issues and administrative issues also playing their part, then I usually recommend using other tools rather than fishbone, because fishbone is very good for technical issues, but sometimes it has its own limitations. I will show you some other tools as well going forward. Then we do some data measurement, existing analysis of data, and we, based on this, we construct a list of facts, and then we compare these facts with the causes. So for example, we say that the leakages take place because we have old equipment, we have old lines, right? But then we also have to check the facts. Do we really have old lines, or when was the last upgrade of lines taken place? When was the last maintenance done? Okay, so we collect all this data. What did they analyze? Did the maintenance analyze any issues with the pipes? Did they do any analysis of the pipes, any infrared or X-ray analysis, for example, of the pipes to see if there are any issues, any rusting going on? So all these facts we have to collect, and based on these facts, we write out some of the probable causes. And for example, we will look at the procurement policy. Does the company have a policy where a company prefers energy efficient equipment over other equipment, or does the company only procure equipment which is cheaper? Okay, so all these facts related to procurement policy, related to engineering, related to operations, we collect, and then based on that we come to a root cause. So we keep on collecting additional data until we come to a root cause, and then we come to point number 9, where we determine the solution. So if we have, let's say, one problem which had 2 or 3 root causes, So one cause was, taking again an example of steam leakages, one cause was that the equipment is rotten or old. Second cause is that the maintenance data does not show that the maintenance team actually did any analysis on leakages or pipes. And third is that the procurement policy does not show that we are preferring energy efficient solutions. So that means that these are the three areas where we have to do an improvement. So we determine a solution which ideally solves all these problems, or we identify three solutions which individually solve all these problems. And for doing that, we also need to do a financial analysis. So which of the solutions that we have identified bring the quickest return? How much saving would there be? Okay, and how can we cater that saving? How much investment is needed? How much time is needed? Would there be a production loss while doing this implementation? For example, do we have to shut down machines to implement this new solution that we're coming up with? How much would that cost us? And if once it is done, how much will be the saving? So once we come up to a solution, pilot this solution in one area and see the results. For example, installing solar PV, we've seen many companies who start installing solar PV with a 5 kilowatt, 10 kilowatt, or even 20 kilowatt solution, and not bigger than that. They install this system on their rooftops and play with it for about 6 months or 7 months. And once they are well versed with controlling the system, then they suddenly go with 1 megawatt, 2 megawatt solutions, because now they are technically well equipped with this. So for example, I told you example of this one company which had 22 stenters, and they already have one stentor which has a waste heat recovery system installed on it. So they already have a pilot there. So for me to convince them to install it on remaining 21 was not a difficult task, because they already have a pilot. They know what are the savings there, what are the flow rates, what are the fuel savings they are getting from it, and what investment that did they make for it, and now they can easily install it. So, and then once we do the pilot, we have to verify the solutions based on the data. So we do again some calculations, measurements, and see if it really is bringing fruits to us or not. And once it is that, when it's done, then we define controls for it. So how would we control this solution now? How do we ensure that whatever we have done is sustainable? So if we have eliminated leakages, will these leakages occur again? If they will occur, which they might occur anyways, will they again occur in the same magnitude, or will we be able to identify them earlier and track them earlier and solve it earlier? And if we have installed a waste heat recovery system, how do we control it? How do we ensure that if we estimated, let's say, that it will give us 2000 MMBTUs of saving annually, does it provide us these savings or not? And how do we ensure that it provides these savings every year rather than reducing it? So we need to have a maintenance plan. We need to have a performance monitoring system installed there to check everything. We need to define responsibilities, who's going to monitor what, and what kind of decisions do we need to take. We need to build scenarios, what can happen. So these are parts of the documentation, how to build a control plan, how to develop standard operating procedures. So this is what comes here. So once you have done anything, always look for standardizing it. So this 5S are actually 5 Japanese words, which the first S is seri. That means sorting. So you sort whatever you have in good things or bad things, or needed things or not needed things, for example, and then you keep only those things which are needed, and then you clean them, clean everything, you put everything in order, and then you standardize it. So standardization means that whatever problems we were having, these must not occur again. So how do we ensure that there is a performance standard now? So how do we ensure that whenever we are procuring a new stentor, it always comes with all the heat recovery options? How do we ensure that if we have a steam trap leakage last time, for example, a steam trap was worn out or it was not working last time, How do we ensure that we have a procurement standard for procuring a steam trap? Who will analyze it? Who will design it? How do we ensure that it does not happen again? And then sustain. So sustain is the part, the last S is the control plan. How do we sustain it? How do we ensure that whatever equipment we're installing has longer life? How do we ensure that our team predicts the problem rather than identifying it when it happens? So predicting it before it happens and takes necessary actions. So this is the most important part of any measure that we are proposing. So when we had issues related to steam trap leakages, for example, we ensured that they make an SOP of procuring steam traps for next time. So how would they measure the flow? How would they calculate the size of steam trap? And so they had to include this in their procurement policy, that next time when they are procuring a steam trap, it is of a certain type, and then they can, it has a certain life. So anyways, so when we start, first of all, remember we identified the non-product outputs. So I just wanted to build a context that whatever we do, we have to first start with compiling a list of energy saving opportunities and non-product outputs. Once we do that, then when we come to this point where we do the prioritization. So this prioritization matrix, this can be used for prioritizing non-product outputs, and this can also be used for prioritizing and comparing the alternative solutions. So for example, this matrix requires to rate measures on the left hand side, or the aspects of the NPOs against certain parameters. For example, results in monetary loss, or causes air emission. So this measure, for example, very low condensate recovery or low combustion efficiency of coal-fired boiler. For example, there could be multiple other NPOs as well. So we want to see that which ones are the ones that we want to prioritize, and which are the ones on which we can work on even later. So we rate them against results in monetary loss, or causes air emissions, or contributes to global warming or ozone depletion, increases fossil fuel use, affects health of staff or workers, contributes to emergencies or fire, explosion, for example, affects relationship with customer. For example, customer is asking us to improve our water efficiency, and if we have a low condensate recovery, that means that we're putting in more water, and so the customer would not be happy because we are actually consuming more water. So it might affect on our relationship with the customer as well. And then legal leads to legal consequences or public reactions. So low condensate recovery does not have legal consequences, but low combustion efficiency resulting in more pollutant discharges might have legal consequences, because when we have a boiler inspection coming in, we might have penalties because of that. And then affects quality or productivity, or affects working conditions on environment. So for example, low combustion air efficiency of coal might affect working conditions as well, because it is emitting high pollutants, which would also cause to the ambient air depletion as well. So it might affect the working condition environment as well. Then increase use of natural resources. Is it increasing the use of natural resources or not, for example? And then based on this, we can do a total of impact, and then we can see which of the losses are scoring high on this qualitative score. So these are the ones which we need to address first, and the others we can address in the later stage. So this is a way that we can, rather than only evaluating alternatives on the monetary loss, these are also the areas on which we should evaluate the alternatives. We can always, because this is not a standard tool, you can always add more aspects to it, whichever come to your mind, for example, in the factories, or what factory is facing. Or you can delete some of these from here as well, and develop your own metrics as well. Sometimes there are these solutions which are highly beneficial to the companies, but they do not implement them. So there is one of the reasons, not all the time, but one of the reasons is that we are only proposing them the solution based on first column, but we are not telling them what other issues they are facing because of this. You can see financial loss is only one parameter out of these 9 or 10 parameters. So if we use this kind of a matrix for prioritizing the non-product outputs, or for the solutions, even for example, what we could do is that when we propose the solutions, we can tell them that there are energy benefits, but there are non-energy benefits as well. ISO 50002 required that in level 2 audits, that is that is detailed energy audit, we provide them a list of non-energy benefits. And in level 3, it also requires us to do a quantification of non-energy benefits. So for example, in this case, if we have air emission issues, okay, so if we are doing a level 3 audit, it is required that we also calculate their air emissions. So how much is their annual air emission volume? It is not very difficult. It is very simple. So let's say we have a value of NOx coming in the sample, okay, and we know that this NOx value is in either grams per cubic meter or ppm, so what we need to do is we need to estimate the total discharge volume of the flue gas. So this would come in, for example, cubic meter per hour. And if we have grams per cubic meter value of one of these, for example, we multiply this with the cubic meter per hour value of flow air. So we get the cubic meter per hour discharge of NOx, CO, PM, sulfur oxides, for example, all these pollutants. And then we multiply this with the number of hours in the year this boiler is operating. So we can tell them how much total amount of NOx, CO, PM, SOx you are emitting. For the textile and garment factories who are using HIG facility environment module, it is a very, very critical issue for them, because while filling in HIG FEM, they also have to give an inventory of all these emissions. So normally what they do is that they have a different person who is filling in their energy module, and there's a different person who is filling in their air emissions module, and both of these are not talking to each other. But the problem this person is having in the air emission module, because this person is getting low scores in air emission module because of these discharges, but this is caused by the energy team, and energy team has to solve it. So this is a cross functional issue, and this becomes a big issue because the factories usually are not able to account it, so they get 0 marks in the air emission section. And although they are able to account it with a simple formula. So if we give them this accounting as well, or we give them a GHG emission value as well, so these are the things that we can account for, and then we can do a rating against it. And this gives us then a good leverage in explaining them why they should implement these measures along with the monetary loss. So then there are multiple tools of doing a root cause analysis. Like we have a 5 why analysis, where we ask why 5 times. So if there is a problem that happens, we ask why did this problem happen, and then you would get an answer, and then you ask another why against that answer, and then you asking why multiple times, or asking a question in general terms, I would say questioning the response multiple times. You come up to a root cause, usually an underlying root cause. Then there's a problem tree analysis, failure mode effect analysis, or a fishbone or a Ishikawa diagram that can be used. For example, let's consider this. It's a simpler example just to make it easy. You go to a company and you see leakages of compressed air from various joints, valves, and pipes. This may result in enormous energy loss. What action would you suggest? So immediate solution may be to repair leakages, right? Obviously, that is what we have to do. But are there other solutions as well to it? What else do they need to do? So remember the DMAIC slideshow, which says that you need to ask when and why this started. You remember this point number 3. Determine when the problem started. Okay, and how did it start? So asking this question, why, how, and when did it start, is very important. So for example, you see leakages, and The reasons might be, for example, the equipment is worn out, or the equipments were replaced but the leakages occurred again, or you see that workers use compressed air for personal and machine cleaning. We often see that workers take out a pipe from the flexible pipe from the machine. They clean themselves, they clean their clothes, then they clean their sweat, for example, and put the pipe back. If they take it every day out and put it again, so this pipe becomes loose. Or maybe the leakages are not even monitored. Factory does not even know that there are leakages, or they are not monitoring the leakages. So there could be multiple reasons to that. So the question would be, why are they not they're not monitoring the leakages? So they never thought of it, or they never considered that it is necessary. Why did they not consider it necessary? So they did not consider necessary because they did not know that leakages are causing so much energy loss. So this means that the energy information is not available. Talking about the other issue, so the worn out equipment were not replaced. Why were these not replaced? Maybe the workers did not report it that the equipment has worn out. Why did they not report it? Because maybe there is no reporting procedure, or it was reported but the funds were not made available. So why were the funds not made available to replace the equipment? Probably because energy efficiency is not considered in design and operation of the facility. So this is something that they don't consider as important. Then we look at the other cause. Equipments were replaced, but the leakages occurred again. Were these low quality equipment, or do we have a very high pressure at the supply side than the demand? So if the pressure is very high in the supply side, there will be leakage in the demand side. So why do we have this gap? Because we are not considering energy efficiency in the design and operations. Or the equipment was low quality, and why? Because we did not consider energy efficiency. We just considered the price of the equipment while purchasing it. So you can see there are multiple causes leading to one root cause. And similarly, you can talk about, okay, workers are using compressed air for personal use because they don't have a cleaning equipment available, or you're not enforcing it properly. They have the equipment, but they find it easy to use the compressed air. So this means that they have lack of training and awareness. They do not know how much loss it is causing. So there could be, you can see that all these gray ones are probable root causes. So what we need to do is we need to have a solution of, and to ensure that energy information is available, that the right procedures are in place to identify and report the leakages, and that we develop SOPs for design and operations of the equipment to ensure that the pressure is not coming with a very big gap. So we don't provide so high pressure than the demand side, for example. Or we have with that we start considering energy efficiency in the purchasing form, and we provide training to the worker. So there could be, you can see that the problem is leakages, but the solution is not only to repair the leakages, but there are solutions in the multiple aspects. So always look at these solutions. So what happens is sometimes because we are so much into the calculations of the savings, that we only look at the replacement of equipment or repair of equipment, and sometimes ignore these management system aspects as well. But when we're working on energy management, these are the aspects which come under the preventive measures. So the one is correction, that we have repaired the leakages. Then the corrective measure is that we install good equipment in that place where the leakages took place. But the preventive measure is to ensure that leakages do not take place in future, or even if they take place, they are identified right at spot. So this is one way of using the 5 why analysis. I mean, just to keep it simple, I skipped some steps in between and showed only 3 why. But my personal experience of doing a 5 why analysis is that most of the time you come to the root cause on asking question third or fourth time. Very rarely we have to go to a fifth to asking a question fifth or sixth time. So if we do a proper analysis of the situation, addressing all the probable issues, then we come to the real cause. and then only we can address this real cause in an effective and a sustainable way. So one part is to do the root cause analysis, but another part that we usually miss out is doing an effect analysis or an impact analysis. So what actually effects does it have? You can use this effect and impact analysis, or you can also use the initial matrix that I showed you. You can also use this one to do the impact assessment, or you can do an impact assessment this way, that you say, okay, what are the effects of these leakages? For example, the effects are that we need frequent maintenance, there is high loading factor of compressors, the housekeeping conditions are getting bad, and so on. And what are the actual long-term impacts of that? So impact of frequent maintenance is that we have high maintenance cost. Impact of high loading factor of compressor is that we have high energy cost, and bad housekeeping conditions lead to demotivation of workers due to bad working conditions. So these compressed air leakages are not only causing the financial losses, but they're along with that they're disrupting our maintenance department, as well as causing the demotivation in the workers. And if the pipes are very nearby workers, I've seen long plumes of leakages at the working height. So if the workers are passing by, they can get a skin burn as well. So these are also some areas when we see that companies are not implementing something because of the financial issues only, but we also need to identify the impacts and effects as well in that cases. Fishbone, I mean, we've seen that. I mean, this is one example which has six aspects. There is the original text of the Ishikawa, Dr. Ishikawa talks about 4 aspects. That is man, machine, method, and material. That is the method I usually take. And the equipment and processes, equipment goes into machine, process and management go into methodology, people that goes into man. So environment actually can be shifted to the effects part in this case as well. So that what are the environmental effects going on? And if we're talking about environmental conditions that are affecting this problem, then this can be shifted to the methodology aspect as well.